There's Sylvia again.
Mm.
I'm running out of things to say.
Yeah.
uh, it's tough not having anybody to talk to all day long. Uh,
I'm just waiting for my dog to talk at this point.
oh yeah,
I could
there
say a
there's
word,
some
it'd be nice.
they're more comforting than people sometimes.
Yeah.
I've got a friend whose dog, who she had for 15 years, died about 2 months ago, and she she was gonna foster animals, and the third one she tried to foster, she was just like, I'm adopting this one. I can't stand this. And so she's so glad she has a dog during this time. So she's got somebody to, you know, somebody or whatever to talk to or to bark at or whatever.
Yeah. I don't know if I'd be good at fostering. I feel like I'd adopt all of them.
I would too. I mean, I get, yeah. I had a dog for a long time. I had a dog for 11 years, and after he died, I was like, I don't know. And I knew if I fostered, I would get one. I visited people who fostered, and I would say, I think I want that dog. So I say, no matter what they had. Okay, let's see here. Let's go down, see what's going on here. Okay, let's see. I got Sylvia, Allison, Brittany, Christina, Damaris, Jessica, Tierra. Okay. So, we'll wait a couple more minutes. Oh, there's Sarong. Okay. Let's see what I got here. Get her in. 1, 2, 3. The worst thing that happened to me this morning is I woke up and found out that Harris Teeter had ice cream for sale. I'm just like, which I will probably make a trip to Harris Teeter, but I'll try not to buy a gallon of ice cream. That's potato chips and ice cream are going to rapidly become my downfall. Okay, I can't get Cerrone in here. What's going on? Come on. All right, I'm gonna share the screen for. I don't want to talk to Siri. No, don't want to do that. Okay. No, still can't get Cerrone. All right, I'll try again in a second. Let me share the screen here. I know she thinks I'm ignoring her, but I'm not. Come on, Cerrone, try again. So here. Wonder if she put the password in. Maybe she'll log out and try again. We'll try again in a minute. But guys, let's just a few words about the test, and then I'm going to do a little something today, and then we'll spend the rest of the time talking about the test. I sent out an email last night with I think I attached it to the email, and I also put it in Moodle. And what it was a the end of there we go, got her in. The end of chapter 4. All of these chapters had sort of a review session at the end, and they're a mix of things. This particular one is pretty good on chapter 4 because there was a lot of theory we had to learn in chapter 4, and it starts out with some fill in the blank, and then some I think there's some true false in there. And then most of the rest of the section is problems to work of all the various types we've done. So what I did on that email and on Moodle, in case you didn't get a chance to look at it, I listed the sections that were going to be on the test. And I made a copy of what was in the book in that in that review section for those of you who don't have the same edition book that most of us are working with. And then I made a copy of the solutions to the sort of the true false questions and the ones that sort of checked you on the theory. Now, the answers to all the odd problems are in the back in terms of ones you actually have to work out. All right, so so we've had a lot of practice in the homework on some of those. So I think those two things together will prepare you well for the test. What I do today, I'm going to just sort of tie up some loose ends in chapter 4. I'm going to show you an alternate way to do systems. Yeah, okay. Saron, can you hear me? She's frozen. I know she's having trouble. Saron, can you hear me?
Yeah.
Okay.
I got it.
I'm sorry.
Yeah,
I had trouble
you.
getting you in. I couldn't. I kept clicking on it and nothing would happen. So, okay. So I'm just going to do an alternate method, a quick alternate method on, which sometimes easier than the one that I've been showing you, and a couple of things about nonlinear equations to wrap up chapter 4. So, I keep getting Siri, and I really don't want Siri at all because I don't want to talk to her. There we go. Let's try this. Okay. Questions, anybody, before I sort of just run through what I wanted to talk about today? The test in general, I'm going to try to, probably the best example about what the test is going to look like is some of these methods are really messy. I mean, we've seen that it takes, a page and a half to do some of these things. Probably a good example to tell you is that maybe that I will, on method of undetermined coefficients, I'll ask you to do one of those where you have to find the YC, and maybe a non-homogeneous one where you have to find the YP to go with it. But remember, the method of undetermined coefficients was kind of that method of guessing. So most likely what I'll do is just get you to run through the process for one problem, and then sort of give you some examples. Well, what if this was the function on the right? What would your guess be based on this YC? Remember, we were trying to avoid duplication and so forth. So we just write the guess. That would be all I would have you to do, because as we said, the guess is really important, because if you start with the wrong guess, you're going to get the wrong answer. Okay. So things like that, I'll try to streamline it, ask some things. I do think that it's beneficial to have some time on these things, because it gets kind of mind-numbing when you're doing DE problems. And I just from sitting and doing them, sometimes I start making careless mistakes when I've worked for a long time. So I'm going to try to post the test late on Friday, and it won't be due until Monday morning at class time. Okay. Next week I'm going to talk about something in chapter 5, and then I'm pretty much going to be done. Next week we'll talk about what's going to go on. I'm going to assign, you shouldn't at this point probably be working on the systems of DEs or what I'm doing today. I'll assign that later. I'll put it on an assignment sheet. What you should be doing is preparing for the test for this time. So the little bit of material that's going to be sort of hanging out that we would not have had a test on, I hadn't quite decided what I'm going to do about that, but would be the DE stuff, the systems of DEs, and the some nonlinear things I'm going to do today. So, questions, anybody? Oh, by the way, on Friday, we're not going to have class per se, but I will be available during the class period for, I don't know, you want to call it an office hour or whatever. If you have questions that you've run into that you can't figure out the answer to or whatever, you can just, what I'll do instead of just standing here in front of the screen when perhaps nobody is there is I'll get you to shoot me an email, and then I'll just I'll tell you, okay, I'm going to set up a time on Zoom for you at 9:15, and then we'll do that. All right, that might be the easiest way to do it. Okay, questions, anybody? I'll stop talking for a second. Anybody problems or questions? Okay. All right, let's talk a little more about systems of DEs. We talked about how they would be applied. We talked about the last couple of days about how we could use elimination to solve them. And elimination is a good way to solve them. But there's another way to solve things that comes in really handy when you have, say, 3 equations instead of 2. With 2 equations and 2 variables, that's how, when you were in high school, that's how you started out solving systems of equations. It was pretty easy. You could just eliminate a variable by multiplying one equation through by one thing and another equation through by another. But when you sort of stepped up the process and you were doing 3 equations in 3 variables, it turned out to be a lot harder. You had a lot more things to eliminate, and you had to make sure that you were systematically eliminating things so that you could, in the end, find an answer. Now, those of you who had linear algebra have had a double dose of how you solve any size system, okay, and the theory about it. But I'm going to show you one today that we've sort of already seen that works better for 3x3s. But before we do that, I'm going to run through quickly the sort of method behind this alternate method. And it is literally, guys, an alternate method. You can still do the other ones by elimination. But this alternate method, as I said, works better for larger systems, I think, right? Or at least for 3x3s, we'll say. Okay, so what I want to look at right now is some operators. I'm going to call my operators now L1, L2, L3, and L4 here. And I might have had in some of the ones that I rewrote last time, I might have written in a problem, okay, D minus 3y, which of course meant y prime minus 3y. Well, I'm going to now refer to D minus 3 as just the operator L1, all right? So whatever this L1 is, it's D minus 3 in this case, then we'll operate on the function y there. This one right here, if we had 2dx, of course it would mean 2 times the derivative of x, or 2x prime. That's what that one would look like. I'm going to refer to the operator L2 as all of that, as the 2d. And what you'll see is that it allows me to write something very nicely in just a second. So so what I've got here using these L1, 2, 3, and 4, these operators, is a system, and I'm only going to do a 2x2 system in this particular case, but what it looks like is a system where you've got L1, L2, L3, L4, the operators you identified, the function x and y, they're functions of t. This is a non-homogeneous system here. It's going to be a lot easier if that's homogeneous, and this method actually will work for that, but I'm going to show you how to do both of these. Normally, what I would do, based on what I did the last couple of days, is look at this system, and I'd say, let's eliminate something. So if I wanted to eliminate the x's, I might multiply that one right there by minus L3, and at the same time multiply this one right here by L1. And what that would do, and I got to do it all the way through the equation, but what it would do was allow me, when I added the 2 equations together, to have that thing drop out. And when it drops out, you got this part right here left. So this is elimination. It's going to lead to a different method here. If you rewrite that, it just says L1, L4 minus L3, L2 operating on y. And if you look at the second, I'm multiplying the whole thing through by minus L3. So over on the right-hand side, it's minus L3 times G1 of t, and that's how I got that. And then when I multiply this one by L1, that's how I got that. All right. So something about this is very suggestive of something we've looked at before, and something that is an easy way sometimes to solve systems. If you look at what's left here, it's L1, L4 minus L3, L2. You could write that in a determinant. So here we are back here at determinants. All right, so that's all that is. And that determinant is going to work the same way it always did. If you want to take a 2x2 determinant, a determinant of a 2x2 matrix, you multiply by these 2. So you cross here and you subtract those 2, which is exactly what I've got right there. All right, so L1, L4 minus L2, L3, y. That's what we get on that side. If you look at when you added these 2 terms together, then you would have, if you put L1 and G2 down in this, and that was the function on the right-hand side of the non-homogeneous equation. You put that G2 down there, L1 times G2 would be this. And then minus, cross the other way, L3 times G1, okay? Now, here's what I'm hoping this kind of suggests to you. It looks a lot like Cramer's rule. And remember when we had Cramer's rule and we were solving for y's, we took the coefficients, all right? And in the place of the y column, we put the functions, the numbers or whatever were on the right-hand side of the system of equations. And in this case, it's G1 and G2, and we left the first column the same, okay? So we were solving for, we eliminated x's here, we're solving for y's. In that y column go the G1, G2. In that x column, this remains the same. Look and see how it sets up in a second, but look at the next one. Suppose I tried to eliminate y's, all right? If I were eliminating, oops, let me go back now, let me go back here. All right, I eliminated x's there, all right? Well, what did I do here? Okay, yeah, I eliminated x's in that one, and it was left with y's, okay? In this one, I'm gonna eliminate y's and be left with x's. See, this is what I'm talking about when I get, I'm gonna put, that's an x right there, okay? I'm gonna multiply through by L4. So I'll get L2, L4, and L4, L1, and then L4 times G1. And then when I multiply by minus L2, that'll give me a coefficient on the y's that will make the y's drop out. So I'll then have minus L2, L3, and minus L4, L2, and then the minus L2 will also get multiplied by that side. So you don't have to do this every time. What I'm doing to do this is to show you that that what you get is this determinant, okay? So it's the determinants we're gonna work with in the end here. So when I did this, the y's got eliminated, and what I had here was an L1, L4. Well, that's what you get on that cross right there, all right? Minus L2, L3, and that's what you got right there. So if you look at that, those two things right there, it's that determinant with the x's left there. And if you look at the other side, right here, if you're looking at the G1, G2, if you put the G1, G2 in the first column, i.e. the x column right there, you'd have G1, L4, which is that, and then cross back over and you'll have minus L2, G2. It looks like Cramer's rule. Remember, we put the determinant of the coefficient matrix in the bottom. In a sense, if you were to, quote, solve for x, that's not what we're doing here exactly. We're solving for x, but we're not exactly dividing by this. But if you did divide by it, you'd see exactly what happened in Cramer's rule. Those were the coefficients. If you're solving for x, replace the x column with the things that appear on the right-hand side of the equation. Leave the y column the same. You're solving for y, put the G1s in the y column, and leave the L1, L3 there. Okay, so it looks like Cramer's rule, and that's how we're going to sort of treat it. So these two give you two